The prologue of the book goes through the history of oceanography. And I want you to know that the prologue goes into way more detail than I'm getting ready to go into in these next 30 or so slides. So if you want to read more about oceanography and the history of oceanography, dig through some of that chapter. Okay, so when we say the history of oceanography, does that mean the history of studying sharks, or is it the history of studying geology? And really, it's all interdisciplinary, right? You can study geological oceanography, which would be the formation of the earth and ocean basins, and really a plate tectonic centric view of our ocean basins. You can look at physical oceanography and the physical parameters that govern waves, currents, tides, sound, heat, light. Also, chemists that study the chemistry of seawater, the composition of seawater. There's salt in the ocean basins, but there's also studies of pH and calcium concentrations. There's lots you can study with the chemistry of seawater. And biological oceanography, so those pelagic, benthic, nectonic organisms, and then the food web and the interactions with those organisms. There's marine engineering. There's a whole field where you can study engineering at sea. It's a little different because perhaps it's underwater and the corrosion is associated with salt water. So there's lots of different ways to study oceanography, and these aren't even the limits. So you could do the botany of the ocean. So many different disciplines with oceanography, and we all build on the history and the science of others. So I'll put myself here with these monsters. Oceans have and still are a place of myth and legend, whether it is Poseidon or mermaids or the Kraken or the Bermuda Triangle. So we think of the ocean as a very mysterious place, and it is. And so from that, then maybe we observe a phenomenon and we try to explain it by using mythical creatures, right? There are some. That's me again over my face over there. There are some creatures that are real, like a giant squid. These are real organisms. They may not be so big that they could capsize a whole triple-masted ship, but they are real organisms, the monstrous giant squids. The earliest interactions of humans and the sea is really food-based. So around 10,000 BC, we're finding hooks that are made out of bones. It wasn't until 5,000 BC that those hooks would be found made of copper, out of metals came into play. Around 2,400 BC, more recently then, the use of nets was seen in drawings on temple walls. So the earliest kind of human interaction was a food-related interaction. Beyond that, in the Mediterranean, around 3,200 BC is when there were voyages that left from Egypt. So from Egypt and just went around the Mediterranean Sea. The explorations continued around the Arabian Peninsula and down into the Red Sea from Egypt around 2,750 BC. And these were, again, just explorations, not so much trade yet until 12,000 to 146 BC with the Phoenicians. And the Phoenicians were a group of people from the region around Lebanon. So if the Mediterranean Sea is kind of shaped like this, it's just right up in here on near Egypt. So they were sailing and trading around the Mediterranean Sea and really started getting that going, the Phoenicians. If we change ocean basins and head south into Asia, in 2500 BC, there were people spreading around from Asia into the Pacific Islands. In the book, there are lots of maps that show the ages. So on this map here, It's the dotted outline is the extent of the exploration, and then on each of these arrows it shows the trajectory and the movement of people and the time that it happened. So in Melanesia and in Micronesia in 2000 to 1500 BC, and by 1000 BC, the population of Polynesia was established, all the way out to Easter Island. There were lots of communities, and a really vibrant trade was occurring then around 1000 BC. The Polynesians were the first group of peoples to really use fancy navigation. And by fancy navigation, they drew the first compass rose, and it was based on the stars, and used a system of mapping that's shown in this image here, so they could map the islands as well as currents around the islands. So they were using navigation and observing the stars. They studied wave patterns and the circulation of the ocean. They also likened what was happening in the sea to the weather. And they understood the migration of whales and the timing of when whales would come back into their waters throughout the year, as well as sea turtles and the birds. All right, just again what I was saying about the weather. They were able to study the weather and predict what would be happening in the ocean at that time. Heading back to the Mediterranean, let's look at some of the explorations by the Greeks. So Pytheas was an explorer that first left the Mediterranean around 300 to 350 BC and went up to England and studied a bit of Western Europe. Some of the other explorers during that time were doing ocean science. So Posidonius was measuring the open depths. Pliny the Elder was looking at the phases of the moon and figuring out how that related to the tides. Ptolemy produced the first world atlas and mapping the ocean basins around 127 AD. Aristotle, a name maybe from the others that you've heard, he began collecting marine organisms, and in that collection, making observations, but also classifying them, so putting them into classes, and realizing the ocean basin's place in the hydrologic cycle, that there was evaporation and that made clouds, and the clouds moved over the sea, and then their precipitation came from those. Aristotle also started to think about landforms, and that the low areas of the earth then would be the spaces that were occupied by the oceans, and that turned out obviously to be true. Okay, back to the Phoenicians and the Greeks. Let me go back. Here's where the Phoenicians started, and they had a extensive trade route that went around the Mediterranean through northern Africa, a little bit out towards Morocco and Spain, and then back through the islands in the Mediterranean of Greece and into Italy, and back to their place back again towards Lebanon. Here's another map. This shows the influence of and really like the supporters in trade. So here's the Phoenicians over here at very eastern end of the Mediterranean, and then the Greek Isles here. Hold on. Where was I? Okay, so let me just say again, this is where the Phoenicians were. These are the Greek Isles and their sphere of influence of where they traded throughout that early exploration of the Mediterranean. Back to Greece, Eratosthenes around the same time was able to put two like sundials, a distance called a stadia, 5,000 stadia apart, and that's about 740 kilometers. And he was able to measure the shadow of one of the sundials and the distance at the same time. And using fairly basic geometry, he was able, as the sun was going straight down, the one at, I don't know which one the vertical was, at Syene, And the shadow at Alexandria measured that angle. And from that, again, using simple geometry and knowing that there's 360 degrees in a circle and that the earth is round, not flat, he was able to figure out the circumference of the earth at 38,000 kilometers, really 30, yeah, really close to exactly what it is. So that was pretty big part of Greek history, and in addition to that, the scientific knowledge at the time. The Vikings were an active bunch. So now we're switched to AD now. The dates before were BC, now we're AD. So within that first 1,000 years AD, the Vikings made it to Greenland and even up into Newfoundland, Cape Breton Island, and down into Nova Scotia. Going back over to Asia, so now we're on into AD. Now we're 14,000 plus AD. Zheng He, he was a Chinese admiral, and so he was part of their. He's affiliated with the government. They weren't really at war, so they were putting him out on these expeditions, and he was able to make a trek all the way around through Indonesia, around the Indian Ocean, hit India, and made it all the way down to off the coast of Madagascar. They had really huge ships that were setting sail, hundreds of them, from China. All right, back to Europe. And here's just a list of probably some of the explorers that you've heard and traders that you've heard of over time. The explorers were, for the most part, like sponsored by trading companies or sponsored by the governments. Prince Henry the Navigator, he was from Portugal. Again, we're back in Europe. He went down into Africa. Bartholomew Dias, he went around Africa, circumnavigated Africa. Christopher Columbus, he in 1492, he sailed over to North America. He was the first European then to visit the New World. Vasco da Gama sailed over into India. All right, Magellan. So I highlight him on his own slide. I'll bring my face back. Ferdinand Magellan, he left Spain in 1519 with 5 ships. He was sponsored by the government of Spain and really trying to find trade routes across different ocean basins. So he crossed the Pacific and made it to the Philippines. He was actually killed on one of those voyages, but his ships continued. So sponsored by the country of Spain, they continued to explore around near the Philippines and through the Indian Ocean over to Africa. So in 1522, the people who took over his ship, the explorers were able to complete the first circumnavigation of the globe. All right, Drake, he's on the same map here with Magellan. He sailed on a boat called the Golden Hind, and he was from England. He was not from Spain, but he sponsored by the Queen Elizabeth, and he sailed around the globe in 1577. Here's just another list of some of the explorers, and you could read through some of the ones I know that I studied when I was studying history in grade school, like Amerigo Vespucci. That's now what America was named after, Amerigo Vespucci. Ponce de Leon discovered Florida. He was looking for the legend of the Fountain of Youth, so other ones. And then William Baffin, went to discovered Baffin Island. So some of these places we say discovered, but like the first Europeans to show up on those places. So just as a side note, like maybe on an exam, this would be something like matching, like where did Amerigo Vespucci go, or where did William Baffin go, Baffin Island, that kind of thing. So I don't really want you to memorize dates. These are all 14 to 1600 AD. So, but be able to maybe match Ponce de Leon with Florida, things like that. Okay. So for the longest time, They were trying to figure out latitude and longitude to be able to find where they were. Relationship between longitude and time was proposed as early as 1530. So latitude was easy. They could figure out latitude. Longitude was the hard one. They couldn't figure out longitude and relate it to time. They were trying to make a clock that could help them figure out longitude because they never knew where they were east west, even though they could figure out where they were north south. So a couple European royalty, the King Philip III of Spain and Queen Anne of England, they were putting out rewards saying, if you can figure out how to sail and figure out longitude and relate it to the clock, then they would give you an award. So over time, John Harrison in 1761 was able to create a clock that could also relate time to longitude. And there it is. That's what the clock looked like, relating the time to the longitude. Oh, there it is. Here's his piece. They were able to accurately keep time at sea. James Cook took the timepiece made by Harrison on his ships, the Endeavour, Resolution, Adventure, and Discovery, and their goal was to chart or map the Pacific Ocean. They had 3 different voyages, and they did science along the way. They did depth measurements, velocity of the current measurements. They took samples of some organisms and were able to collect real scientific data at that time. Your book goes into some of the discoveries that they made over the course of those 3 voyages. Benjamin Franklin, he was not only like into politics that we think of him as being in, but he was also into trading. And he was living in Boston at the time and decided information and resources need to be moved faster between England and America in the late 1700s. So he mapped this really accurate map with the help of others of the Gulf Stream. It's just a fast current, and we'll talk about the speed of currents later in the semester. But here's his map of the Gulf Stream, and look at the modern day map. It really coincides very nicely with the map that he made in 1769. Okay, Darwin. I'm going to just turn my face off. Okay, Darwin. In the early 1800s, Darwin was taken aboard a ship, the Beagle. He wasn't the captain of the ship. He was the person in charge of data and science on the ship. And they went out to the Galapagos Islands, and they are right here. And that's one of the places he caught the idea of evolution. So the voyages of the Beagle, the voyage of the Beagle was when he was really finalizing his thoughts on evolution. All right, Thomas Henry Huxley. Huxley was doing science at the same time Darwin was. They were buddies. And there was this weird goo. Let's see if I can pronounce it. Bathybius heckerkelly. The goo, the mud. It thought to be a protoplasm. It turned out it wasn't. It was just a gooey mud from the deep sea. And they were thinking maybe it was like one of the earliest life forms. It turned out just to be a gooey mud. But so he was sponsored on explorations to go look for this gooey mud and to think about its place in evolutionary history. All right, the Challenger expedition. This is a big one from the late 1800s. Here's the date. So 1870s. And this was Charles Wyville Thomson, and he was sent out to explore again the Pacific Ocean, and in that got depth measurements. Depth measurements at that time were literally taking lengths of chain and sending them overboard with like color coded stops on them. And they got what these depths by soundings by these chains. So it took a really long time to send the chain down and bring it back up. So 361 locations they got as depth, and they discovered the maximum depth of the Marianas Trench was 28,850, the deepest place in the ocean. In the late 1800s, they figured that out. So they were mapping the seafloor, and they were noticing that this is important here, showed that the relative abundance of major component ions in seawater remains constant regardless of where a sample is taken. What that means is the ocean is so mixed up that the chemistry of the ocean is fairly constant. So that was a big discovery during the Challenger expedition. Then they discovered almost 5,000 new marine organisms while they were out there collecting samples. Here's some of the science related to it. So diatoms and other plankton. They did wet science in their labs and measuring and weighing and sketching and the Fram expedition. So the Pacific and the Mediterranean were places of discovery. And in the 1800s, they started going more towards the Arctic. So this is Frentoff Nansen from 1861 to 1930, a long amount of time. They went up to the Arctic, and they had these ships that were really strong, that they could allow them to be frozen into the sea ice. They're really strong, tough ships. And they, one of his big discoveries at that time was the Ekman spiral. And we're going to study the Ekman spiral when we look at ocean circulation. What it's saying is like when the ocean's blowing one way, you have at the same time the Coriolis effect, the world is spinning. And so it takes the spiral of the water column as it goes deeper, then it changes the direction of the water current based on where we are with the Coriolis effect. So we'll talk about that when we talk about ocean currents. They were looking at chemistry, the weather, the Ekman spiral, the nature of the Arctic Ocean during the Fram expedition. There are many other polar expeditions. James Clark to the Arctic and Antarctica. The Fram, where they got frozen into the ice. Shackleton, Robert Falcon Scott, and Richard Byrd. And these were expeditions in really harsh places in the world, right? Really cold and desolate and not a lot to eat. And so there's a lot of sickness and starvation along with these different expeditions, and your book goes into each one. I'm not going to, and you can read about what happened on each expedition. Okay, in modern time, so by modern I mean the 1900s, we're looking at Harry Hess. Harry Hess was in the Navy, and he was a geophysicist, and he took soundings and figured out the bathymetry of the sea floor was not constant, that the seafloor had topography, and discovered what we now call the mid-ocean ridges. So in the middle of our ocean basins are vast mountain chains called the mid-ocean ridges, and they're places where, when we talk about plate tectonics, we'll learn about how the plates are moving apart at the mid-Atlantic ridges, mid-ocean ridges, mid-Atlantic ridge being one. So here's the mid-Atlantic ridge coming down the middle of the Atlantic Ocean into the South Atlantic here, and that's a place where plates are spreading apart. So he discovered those, and he was an American. All right, these days there's the ODP, so you can get a job or get funding to go out on the drilling ship. The current one is the Joy. Well, they started with the Glomar Challenge. I believe it's now in dry docks. I don't think it's out at sea anymore. The JOIDES Resolution was one for a very long time, and now they're still using the JOIDES, but now there's the Chikyu as well, and they're huge ships that are drilling platforms, and they have the ability to stay in place so that they have to keep they drill, basically it goes through the water and into the seafloor, so you have to keep the ship really still. And so a big part of that is that machinery in the ship is keeping it in one place, but it's a big drilling rig. There are also less fancy but still pretty cool, these Argo floats. And there are 3,000 independent floats. I think some of them are offline these days, but they can go deep down in the sea and then come back up. And as they go down and up, they're measuring data the whole way down and the whole way up. And then each of those Argos has a way to radio the data back to satellites. And so we've collected a ton of data about the water column, so how the temperature and salinity change as you go down into the sea in many spots around the world. Okay, so that's it for oceanography. There's way more to this chapter in the book if you're curious more about the history of oceanography.